Welcome to another video from explainingthefuture.com. In my last 3 films, I've discussed how in the future we may obtain resources from space. This time, I therefore thought I'd show you how those films were made, and in particular how I tried to strike a balance between scientific accuracy, production practicality, and making shots that would just look good in the final films. The starting point for the Resources in Space videos was the construction of 3D models in a package called Lightwave. Textures and other surface properties were then added before the models were lit with virtual lights and filmed with virtual cameras. Most shots were test rendered several times to check the timing and basic animation. Once everything was okay, more time-consuming final renders were then created. On average, final renders took several minutes per frame on a fast quad-core PC. In total, the 3 Resources from Space videos required nearly 2,000 hours of render time, resulting in over 48,000 frames or frame elements. Data handling was therefore not insignificant, with the 3 films producing over 54 gigabytes of data. I also ended up with a vast quantity of paper-based notes, as well as lots of very rough drawings that guided the design and construction of final models. Once individual frames or elements were rendered, they were composited in Adobe After Effects. Particularly in the space-based solar power video, shots were often built up from many different layers, such as a space background, the Earth, energy beams, and a solar power satellite. In addition to compositing, all text and special effects like energy beams were created or enhanced in the After Effects package. Back in August 2013, the first model to be created was a space capsule and support module. In the videos, I wanted to portray a generic but realistic space future, and, following the retirement of the space shuttle, at present it looks pretty certain that most manned spaceflight in the next few decades will be capsule-based. Granted, Virgin Galactic and some other companies are developing space planes, but these seem unlikely to venture that far from the Earth. I therefore built a model representative of the Orion capsule now being developed by NASA, or the Dragon capsule from SpaceX that will soon carry astronauts to the International Space Station. Like all of my models, the space capsule and its support module evolved through a great many iterations from basic geometry through to a final design. The ship was then reversioned into several different spacecraft, including my rocket trains, lunar lander, and the limpet ship Asteroid Miner. Overall, the modular approach not only saved me a lot of time, but also brought a visual consistency to the 3 videos. In addition, opting for a modular construction approach was, I think, also realistic, as the development of modules that can be reused in different configurations is likely to be essential for space travel to become more cost-effective. From the outset, I decided to light my shots as realistically as possible, with a single key light representing the sun. This produced hard shadows, but I think added atmosphere to many shots. I did, however, relax my realism when it came to my backgrounds. Out in space, while millions of stars would be visible, they would be very faint compared to any planets in view, or indeed any spaceships or space stations lit by the sun. To be realistic, the backgrounds in almost all of my shots therefore ought to have been totally black. On the Moon, I decided to adopt this realistic approach, as many people are familiar with shots of the Apollo moon landings with their black skies. But in all other space shots, I used a model of about 500,000 stars to enhance the visuals, and in particular to provide a sense of orientation during complex camera moves. As Captain Kirk once said, space is the final frontier. In these videos, I've enjoyed trying to illustrate what going across that frontier may actually be like. Further, I hope I've inspired at least some of you out there not just to think about space in the abstract, but to get involved in the science and the engineering, and to actually in your lives create the rocket ships and space stations and solar power satellite that we'll need in the next few decades to obtain more resources. So, with a nod of thanks to the future space pioneers watching right now, I'll say that's it for another video, and I hope to talk to you again very soon.